sorted. So last week I was talking about, I was going to bring in some things. So, another way to talk about, like, with ANOVAs, the two-way ANOVA is, like, what type of model it is. So, I think we talked about when there's, like, two main effects and no interaction effect, like, that's a thing that can happen, or if there's no main effects and, yes, interaction effect. So, if there's two significant main effects but no interaction effect, we would call that an additive model, just because it's saying that like the separation of the two factors makes it significant, but them together doesn't. So that would just be called an additive model. And then when there's no main effects, but yes, an interaction effect that's significant, we would call that an interactive model, and that wording makes a little bit more sense because the two variables are interacting to make a significant effect on the dV. So yeah, that's just a thing. And then also, did you guys talk about post hoc tests at all in class? Mm-hmm. Okay, cool. So what did you guys go over with Dr. G? Bonferroni. Is that kind of all you covered?
Bonferroni, Chaffee, and Tukey.
Okay, cool.
Also, Visual LSD.
Okay, so yeah, the spectrum of them. What kind of stuff did she cover at that? Like, did you talk about how power comes in and how type 1 error comes in with those?
Yeah.
Okay.
Type 1 error.
Yeah. Cool. So, do you have any questions about that? About those?
Kind of. So, my understanding from the lecture was that the Bonferroni would be like the best one to do because it gives you the least chance of getting a type 1 error.
Mm-hmm.
So why wouldn't we just always use it?
Yeah, I think sometimes there are, there's just other options and ways that you can do it. So there's when I learned it, it was more like a spectrum from liberal to conservative.
Yeah. And
so it's kind of just depending on what is in the model, like in your design, that type of thing, and just knowing like different types of doing it. I felt, Bonferroni is a pretty solid estimate. It's kind of in between the two. It's not taking in too much into consideration, and it's not like being too lax. So it usually is the best option. I think it's just trying to get you to like know that there's other types and like what takes in stuff. And I think some of you noticed that equal variances need to be assumed for some of them. Equal sample sizes are necessary. So it's just kind of depending on what is available to you. So liberal tests generally maximize like the power that you have in the study, but then they kind of increase your type 1 error risk. And then more conservative tests reduce that probability of the type 1 error. But then they compromise the power. So that's why I think Bonferroni kind of does the more of a balance act between the two, because as you kind of lift one up, the other kind of is diminished a little bit. I have some pretty good notes on these too, so I can send that to you. Because like I said, I'm still not very. I don't feel like I don't understand it, but I do have notes.
Why can't we do planned comparison instead? Like, why do we have to do a post hoc?
I don't know why that it's like that in the curriculum, because we only learn like the post hoc tests. I think the planned comparisons like have to take in a little bit more like context before you do it, and that's just not really necessary for like how the lab is set up, because we're not like researching and like delving into a topic. But otherwise, I don't know.
I was kind of confused because like on my output before the post hoc, it said planned comparisons, but I didn't run planned comparisons, but that was like the title of the table that showed up.
Yeah. I don't know.
I didn't know if I could reference that, so I didn't. But Dr. Guadagno had us like do it in class.
Mm-hmm. I mean, I think it's always good. You can always, like, reference things in the output, even if it's not, like, asked for.
I'm just wondering why it showed up.
Honestly, I have no idea.
And if that is actually like a plan comparison or just title plan comparison.
Yeah, I'm not sure,
I
honestly.
don't understand SPSS.
Before you ran? Like
It
you
just-
didn't click post talk.
I clicked post hoc.
Okay.
I did the whole thing,
Okay.
and as I was scrolling through before the actual table with the post hocs, it said planned comparisons, and there they were.
I'm not seeing it.
Let me see if I can pull it up.
Control F not working for you.
Oh, pairwise comparison.
Ah.
okay.
Ah.
Yeah,
Okay, ignore me.
That's different.
What is that?
so it's taking into consideration, like, comparing which one. Yeah.
And then it was here too. That's why I thought it was.
So, does anyone have any specific questions about the homework?
The last question.
The last
about
question?
the
Omnibus F. Okay. I'm gonna open it.
I think mine was number 5.
About the cell
Marginal.
and marginal means. I forgot that question was on the homework, to be quite honest. But let's address that because it's pretty easy to fix or like get on.
How do you write on a PDF?
I forgot that it was on there.
that too.
I don't remember how I did it. We did it last year. I think I just highlighted it.
You can just open the PDF and preview. You can annotate previews.
Like when I click on it and it opens with Adobe?
Well,
It
if
wasn't an option.
do you have Acrobat or
On my
Reader?
laptop?
Have Acrobat or Reader?
Acrobat?
No, Acrobat. You can annotate. There's annotation tools. You can just draw on it like crazy. And if that didn't work, you could open it in preview and then use the pen tool in that.
So would you like us to go over the one-way between groups ANOVA, or should we just focus on the two-way? Any preference? Okay.
Two-way is fine.
Two-way, yeah. Okay. Another important thing to just note is that just a reminder for the assumptions. For these, you need to have either, like, we want to have both the normality and homogeneity of variance, like, assumed, but it is okay to have only one of them to move on with the testing or the analysis. So it's just one of them that we need. Okay.
Sorry, one of which?
So for the assumptions, it's like homogeneity, variance, and normality are kind of, you just need one or the other or both to move on with the analysis. You don't have, so if one of them isn't met, you can technically move forward with the analysis. But also that's like a red flag, so like in real life you kind of be like, that's shifty, like that's shady. But technically you can, as long as you have one, you can kind of move forward.
So like in the one way, it seems like the normality was violated,
Mm-hmm.
but since the Levine's test was fine,
Mhm.
then it was fine.
Yes, and then another thing to remember with the normality is the central limit theorem, too. So that's always a good thing to be like, I did all this work with the normality, but in the end, the groups are more than 30, so we can invoke the central limit theorem and we can say that normality is cool. So that's always a good thing to fall back on. Okay, so null is that in the population, we always have to break it down between the main effects that we have and the interaction effect. I think for the two-way ANOVA, we're always going to have just the two factors. If you add a third factor in, you're going to have two interaction. Yes, two or three. Wait. Shit. Because you'd have to be 1 and 2, 1 and 3, 2 and 3. Yeah. Yeah, it'd be 3. So, and that gets really messy, and we're not going to do that.
You wouldn't have an interaction of all three at the same time?
You would. You're
So
correct.
It would be 4.
There would be 4. Does that make sense? Sorry, that was... Okay. Anyway, that's for another time. So yeah, we're always going to want to look at the main effects, 1, 2, and then the interaction effects. So that applies to our null hypothesis and our alternative hypothesis. We're going to have 1 each for each of those. And then alternatively, when we interpret the results, we're going to interpret them main effect 1, main effect 2, and the interaction effect. We're always going to have 1 of each for each of these questions, basically. Just a good way for the null hypothesis for the main effects is just in the population, all levels of factor A have equal marginal means. Just equal marginal means. A good way to do it. And that's the same for factor B. And then in the population, there is some inequality or some difference between these marginal means in the population because we don't know where that lies unless we have 2 levels. So if we have more than 2 levels, we don't know where that difference is. And then for the interaction effect, in the population, the effect of each factor is consistent across each level of the other factor, or no interaction effect. So yeah, again, we're going to need the assumptions are going to be normality, homogeneity of variance, and independence between and within groups. So a good thing to kind of learn or put in your mind is, so that kind of last little assumption, independence. So you need to know when to apply between and within to that. And a good way to know that is basically you're always going to have within, because you're going to have at least one sample, one population, one group of people in your study. So you're always going to want to make sure that there is independence between those people. So that's always going to be there. The between comes in when you have separate groups that are not taken from different areas or different on one aspect of them. So knowing when to apply the independence within and between is a good way to kind of check yourself when you're writing out the assumptions, that type of thing. Okay, so why don't we run the analysis. So analyze, we're just going to assume we did all the checking for normality. So analyze general linear model, univariate. So our independent variable is going to be salary. And then our fixed factors are going to be ethnicity and gender. No contrast, plots, post hoc. So our ethnicity one is the only one with more than 2 groups. So we can run our tests. Options. Display. So homogeneity tests, estimates of effect size. I went ahead and put the descriptive stats just so it'll come out with that. continue, and that's all we should need. Okay, so we got lots going on here. Okay, where to start? So reporting the results. We are going to want to use 3 different F statistics because we have a main effect 1A, main effect B, and then the interaction effect. So we're going to do the same type of reporting for the results for each of those. And you're using basically the same structure, same wording, just with different factors or the effect. So we're going to look at, if you want the factors, you have the ethnicity and gender. So we're going to evaluate that statistic for this one and then do our whole thing. So this is the F statistic. It was significant with the DF. And then we're going to say the effect for factor A, ethnicity, was significant. So therefore, we can reject the null hypothesis and say that in the population, the marginal means were not equal to one another. So we do that. So then we go into the next one, which will be gender, and so we'll say there was also a significant effect. You can reject the null hypothesis, yada, yada, yada. Same thing for that one. And then moving on to the interaction effect. So, yeah, whatever. Moving on to the interaction effect, we'll do the same thing, but for this one, we can see that it's not significant. So we would just note that, say that we failed to reject the null hypothesis, and that's that. So then the next step is interpreting the results using our effect size, and the way that we do that is the partial eta squared. And so just like with Cohen's d or any effect size, the only time that we're going to use it is when we have a significant effect. So because our 2 factors are the only thing significant, we're only going to figure out the effect size for that. So what we do is we use partial eta squared. And so does anybody remember how we interpret this number for
The percentage of effect.
Yes. Yeah. Percentage of variance. So it would be in the population, ethnicity counts for 10.4% of the variance in the DV. And then alternatively, the gender accounts for 15% of that.
When you're doing the degrees of freedom, was the second number the error or the total, or the corrected total?
Error. Yes, I believe so.
Can you say one more time how you would report it?
The partial eta?
Yeah.
So you would say something along the lines of the partial eta squared tells us that the factor A, ethnicity, has 10.4%. It accounts for 10% variance in the DV of salary in the population. So 10.4% of the variations in salary are due to ethnicity. And so then alternatively, we can say 10% or 15% of the variance in salary is due to gender. And then I think last week we mentioned the partial eta squared is 6.7%, but using our F statistic, it's not significant. So we would say that 0% of the variance is explained by the interaction of those 2 variables in the DV.
Do we have to say that?
Technically you can, but no, you don't have to.
Why wouldn't you just say 6.7%, but it's not a significant effect?
So the only time, I don't really know why, but it's kind of counterproductive because the effect size is trying to say how big the effect is, but if it's a non-significant effect, it doesn't really matter if it's 10 versus 6%, because it's just not significant. Yeah. Cool.
Can we talk about how we would report it in like the statistical way, like capital F parentheses the number of
Yeah,
groups versus the number of participants?
You can do it the way that it's in the packet, or alternatively, you can use the APA style.
I was just wondering, like, because I reported it using the APA style, but I don't know if I did it correctly.
Mm-hmm. Can I see how you did?
Yeah. So, I don't know if are these numbers correct? Like gender, because there's two genders, would it be 1 degree of freedom, or because we're looking at like for ethnicity, there's 3 groups, but it said that the degrees of freedom in the output was 5. Is that because they're looking at like 5 different individuals? Like they're counting gender and
I don't know, honestly. But this looks good, like the way that you wrote it up. Yeah.
I'm just curious.
Oh, actually,
like, if these are like, is that number? Should it be 5 or should it be 2? Because there's 3 groups.
I've always just gone with what the outputs.
Okay,
But
output's
that's a
fine.
good point. I don't really know.
Okay.
But another thing is, I want you to write up like a sentence for each.
Okay.
Yeah, just so you know. A sentence for each effect.
Mm-hmm. What was I gonna? Or like at least addressing in like paragraph form. Does that make sense?
Mm-hmm.
I think you might have looked at the corrected model FDF maybe.
Can we go higher?
Mhm.
Right there.
Oh, this one. So go with the one down here that corresponds with the factor actually.
Okay.
So because use this row basically because this is all the information about this factor.
Where would we get the number of participants? Like. So for the first one, we would use, because it says in degrees of freedom for ethnicity, we would use 2. But what would we put? Would I still use 84 based on the second degrees of freedom for the number of participants? Or
Yes. But I think a good way to do it is use this table because as you'll see it's the same number. But does that make sense?
kind of.
Yeah. So it's always going to be whatever factor you're looking at and then the error for the DFs.
Okay, so the second number we're reporting is the error.
Yeah.
Okay, always.
Yes.
Okay.
I don't know about always, but in this
So like
test,
if I were
yes,
to
always.
report gender, I would say F parentheses 1 comma 84, not 89.
Yes.
Okay.
Yes. Cool.
Thank you.
And then so moving down to the post hoc tests.
Oh, did we do the marginal means and cell means?
Yes, I'll go back to that in a second. Yeah, so post hoc tests, we're looking at where specifically the differences lie. I think for who I looked at, I think everyone pretty much addressed that correctly. Just choose one and say, just choose one, say why you chose it. Just so you can say Bonferroni is a good one to use because it's mid-level and it does what you need to do.
So you need to explain why you're using the test that you're using.
Yeah. And honestly, just give a reason, and I'll say that's great.
Why did it only do it for ethnicity?
Because I only put ethnicity in because in this data set, the gender only has 2 levels. So I only put in the ethnicity to there because I knew that when we see the omnibus F for gender is significant, we already know that there's like a difference between the 2. We don't have to see where it's at.
So even though I put both of them in, it didn't tell me anything because there's only 2.
Mm-hmm. Yeah. Yeah. But in real life, there's more than 2 genders. Am I right?
You're right.
Okay, cool. Yeah. So, yeah, Asian American and Latino American individuals had a significant difference in salaries based on the SHFE, also in Bonferroni, also in the CDAC.
So would you want to use more than one postdoc?
You don't have to.
Okay.
I just clicked.
Okay.
I was confused about that. Like, is it okay if we just run stuff but don't refer to it? Like,
Yes.
we have to go back and rerun it with just the things we're going to use.
If you, whatever you need to do or run to like understand, or if like you mess up, it's okay. Like I basically just try to run through your output to make sure that you ran the correct things, and if there's like random things that you don't use, like that's totally fine. Like
Okay.
yeah, it doesn't matter. Yeah. So good on that.
I'm just a little confused. Even though there's 2 genders and there was no interaction effect here,
Mm-hmm.
like there still could be a difference between male Asian Americans and female African Americans.
So
Yeah.
I actually had that in the descriptive statistics.
Mm-hmm.
Like, it gave me.
Right, but it
was a
doesn't
good
do
way
that
to
for it
Mm-hmm.
doesn't do that for the post-hoc.
Well, there might be a difference, but it's a difference that could conceivably have been due to chance.
Mm-hmm.
That's the big difference. Like when you get the significance number, it just means what are the odds that you got this result due to chance.
Mm-hmm.
And when you have significance, it means that there's only a less than 5% chance that these results were due to chance.
Right.
So you can see a difference, but it's a difference that, according to the convoluted math of statistics, could have actually been due not to the qualities of the population, but due to just random sampling error.
But we won't even know because it's not displayed.
Yeah, it is. You've got an insignificant F result.
Mm-hmm. So that's what
Right.
it's saying, though, is that you can look at the descriptive stats and look at the means between males, females, Asian individuals, etc. But what the interaction effect's saying is that it's not significant based on those 2 variables together.
Like conceptually I'm understanding, but technically, as far as SPSS goes, if there was a significant interaction effect, would the post-hoc have shown both levels? Or would it still have done it by ethnicity and then excluded
So-
gender?
The post-hoc tests are only referring to like the separate,
The main effects?
the main effects, yeah.
Okay. So yes, it still would have excluded gender even if there was an interaction effect.
Mm-hmm. Mm-hmm.
There wouldn't be a way to break it out to see what the effect is.
So I still don't get the point of post-hoc.
If there's an interaction effect, then what? How do you?
Like a planned
Post-hoc that.
comparison would be the best way to do that. It seems like. Because you can actually pair everything up together.
Okay, so that's part of what they wanted to know, right? Was if there was.
I see.
Yeah. I don't know. This is something.
Sorry. I just wanted to know if
No.
it was just in this case because we didn't find an interaction effect and if like in the future, but it seems like you're saying if there's 2 levels, it's not going to show up regardless if there's an effect, and the post hoc doesn't show the interaction anyway.
Mhm.
Okay.
I have a general question.
Okay. Yeah.
How old is SPSS, and are all
Hella old.
statisticians like happy with the way that it is? And at one point, are we gonna like?
So
move
actually,
on and-
funny story. I was meeting with Dr. Tiet, who is my advisor, and he was like, yeah, because I was talking about how like I want to do research more, blah blah blah, and he was like, you should learn like another program because SPSS sucks, and I was like, cool. Why the hell do we learn
Right.
it? It makes no sense, which is really unfortunate, but it is what it is. I think SPSS is the easiest to grasp, and that's why they've used it for so long. Also, they've used it for so long, and they don't want to change it because change is hard, and we don't like it. But on that note, so there's M+, which is good, and then R. Do you know other ones? Like, there's a lot of...
SAS.
What? SAS, yeah.
And probably the reason they're still stuck on this is because the volume license for this is mega expensive,
Yeah.
whereas ours is free.
Yeah.
So
Yeah,
since
exactly.
they've
So it's
obviously
like...
paid bajillions of dollars to volume license it on all 10 billion campuses.
Yeah, exactly. And so a lot of politics goes into it, and it's really unfortunate. But I think I've looked, like, the different programs, like, they have their own nuances, but as long as you kind of understand the ideas, you can, it'll take you, like, a couple hours maybe to learn the new one. Like, for example, I'm planning on learning, like, R this summer, hopefully. I don't know.
The thing with R is that it's still pretty much all syntax. So
Yeah.
if you grew up using,
Yeah.
like Rosanna did, if you grew up using SPSS through syntax, then it would be fine. Or if you
Yeah.
can write Python, you're fine.
Yeah.
Because that's kind of how R works.
So we didn't really address the syntax in here because it's not something that we've done, but like basically it's like coding, and that's a whole nother language to learn too. So it is unfortunate that we learned this, and it's kind of, and another thing is that it's really easy to learn. So like almost all students use SPSS for their dissertation and projects, so it's just kind of more simple to use. And it kind of gets you out of the door basically, and then as you develop, you can kind of add these other ones too.
When I learned R in undergrad, we only did it like through syntax, and it just
yeah.
made it the hardest thing in the world.
Yeah, so that's yeah.
Well, the R GUIs suck.
Yeah.
So you wouldn't have wanted to do it the other way.
I also like didn't know how to code, so it was like doubly impossible.
Mhm. Yeah, and that's like a whole nother skill to kind of learn. So, but I really want to, but I don't know where to begin.
Berkeley has some free art classes that they do sometimes.
Nice. But yeah, so and then so are you guys in advanced psychotherapy yet or something? Psychotherapy, principles of psychotherapy. So anyway, we had a adjunct professor named Dr. McCollum, and he was like, yeah, like when I was in grad school, I just learned R for fun. Like I had a bunch of free time and I did it. And I was like, who are you, dude? Like what? It was like, okay, you're cool. But yeah, so that's a whole thing. Okay, so cell means and marginal means. So I wonder if I can just find a good like table of it, because I don't like the way SPSS puts it out. Okay, bear with me for like a second. I'm gonna see if I can pull up Dr. Menon's thing. Okay. So this is how you do it by hand, which is like a nightmare, but it makes sense. So the cell means are each individual thing. So this is talking about sexotherapist type of psychotherapy. So the cell mean is going to be each individual. Yeah. So these are the different participants, I think. Oh shit. Okay.
I think you're right. It like was pointing to the M in each box as the
Mhm.
cell mean.
Okay, cool. And so what the marginal mean is saying is that it's the mean for each and every person in the psychoanalysis group. Each and every Jungian group is going to be the marginal mean. Each and every single behavioral person, blah, 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 right? And then, alternatively, the marginal mean for males is 20 across all of those groups. The marginal mean for females is 30 across all of the groups, right? And then the cell mean is going to be for each combination. So 6. So psychoanalysis in male therapists has 6. Cell mean for females in psychoanalysis.
Okay, so that's
Like, you understand the concept, and then I'll show you in SPSS what it looks like. And so it's just saying, like, what mean are we looking at here? And then, so these were, if you were going to do the math, like, the cell mean is these 3 participants' mean together. So you can see that it would just be 6. Yeah. So then in SPSS, it's like not set up so nicely. But as you can, when you, ooh, hello. I don't know how to get that back.
The mouse is there.
Weird.
I think you have to drag it. It was like over on the side. There it is. Do you see it on the left?
What? That makes no sense. No, it's not on my screen. Oh, because it's, okay.
It's like as if you had 2 computers
I
in
don't
front
like
of you.
that. Okay. So, in the options, so when you do the analysis, like one of the things is the options thing. This is where you click effect size, and then you turn over the variables into means. So you do the factor 1, factor 2, and then the interaction, and that'll give you the marginal means. So it breaks it down by ethnicity, gender, and then the interaction ones. So these are just going to be the marginal mean for each group. And then these will technically be the cell means for the interaction.
So what are the margins?
These are the marginal means.
Okay.
Yeah, for each. And then these down here are the cell means.
Okay.
And then the grand mean is that overall, like, variable. So this is the grand mean out of everyone in the study. That's the mean. Out of everyone?
Can you scroll back up to your, like, the F results? Where did you click to get partial eta squared?
So that's another thing on the,
Options.
yeah, in the options. So,
That's another effect size.
What do you click at the top?
So, option.
Analyze?
Yes, so analyze.
Analyze. Did you run it as an ANOVA or as a?
ANOVA, or no, the general.
Yeah, so it's under
model.
options, and it's estimate of effect
Okay.
size. So you got descriptives, estimate of effect size, test of
Oh, it's
homogeneity.
not up there. Come on, guys. Come on. There we go.
Okay.
I don't like.
Yeah,
How do I do?
did that.
Okay. Yeah, so you'll put over to get the means, estimated marginal means over for each one. Descriptive, I just put descriptives in there for whatever. Homogeneity to get the homogeneity stuff, and then estimated effect size. You can add like all of these if you just want to look at them for fun.
Lack of fit.
Yeah. Woo. Yeah. Does that make sense? Cool. Any other questions? About that? I think that, let me look at the PE for next week really quick and see if there's, how similar it is.
Is it 2 questions?
Yeah.
Are we gonna have time?
Yeah.
It took like 2 hours to do this.
Yeah.
It was very taxing.
Part of it's just the tiresome quality of writing up all of
Mm-hmm.
the normality stuff. Can we just pick one and move on?
Okay. Circle and label. Okay, so there's a question on the PE about marginal means. I'm just gonna take that out.
Take 1 question out.
You just take them all out.
Right. So what I'm gonna say is that I suggest just like answer all the other questions except for the normality, and then do normality last, and just do however much you can, because even if it's not assumed, I'm gonna have you run the analysis anyway. So like that's like the least important part of this exercise, but at least mention it. Just do that last. Does that make sense?
Just a quick review. So for normality, we use the KS test system.
Mhm.
Yeah.
Yeah. So
Sorry.
go ahead.
I'm just gonna review. So normality, KS test, homogeneity, Levine's, and then for independence, that's based on the design.
Mm-hmm.
Okay.
It's basically just saying we trust the researchers.
Right.
But it is important to know like when to do the between and within, because then that is really important as we move on with more analyses too. So
Like in the instruction manual, the words say that we know that there's within group design because of random assignment, but none of these studies were applicable for random assignment because like you can't assign gender or ethnicity or job
Yeah.
or school, like
Yeah.
So what do you say?
Good point. I think just saying that, making the point that we have no reason to believe that the between groups were connected in any way. Like, yeah, there's not much you can do about it, and that's fine.
Oh, so that's between groups.
Mm-hmm.
So the systematically linked part is within
Mhm.
groups.
So yeah, it's just saying that like all of the people in the same gender group, like none of them are like I don't know, family members or something, you know? So, I don't know, something like that. That's all it's saying. Anything else that's important? Yeah, I think that's about it. If you have any questions, feel free to email me, talk to me on Monday, stuff like that. Again, with the time thing, we have an hour set. Last year we had a lot of problems with like timing. Like my group really struggled with that. So like we had some time extensions. Don't stress about that like as much. Like if you're going over a little bit, I'm gonna be a little lenient on it, to be quite honest. Because most of you have gotten done before the hour. If it was like a huge thing, we would have to set like limits on it, but don't worry about it. Just do what you can. You can do it. I believe. I believe in you.
These grades get incorporated into our staff grade, right?
Mm-hmm. Yeah.
I have a question for you.
Did you
we?
write those down?
I have them written down. I have it at home now. So.
Did you want to?
Yeah.
There I can hiss.
Did you get the notes, by the way, or did you want
Yours?
just?
That's okay. If you want, you can do it. If you really feel like it.
If I get to that point of my studying.
I was looking at you ordering food, and I was like, I'm probably gonna order food on my way home, so I can just Jesus Christ, what is wrong with you two today?
If I fall, I don't
need
have
to
to stay
tomorrow.
What
Is that how
test?
it works?
Is it bio?
Bio.
push each other. That's how a suicide.
Right, you throw me, you throw me down the stairs, I'll grab you so you fall down the stairs with me. You can do this. It's okay.
That doesn't sound very healthy, you guys.